We start the recording. So last time we left on the coding part. So we are dealing with the multimodal RAG, and we have discussed that there are different approaches. The We have seen the entire pipeline. We have seen how the unstructured document, which can be a PDF or an HTML document. So these documents are not just piece of text, rather they are having images or tables and some complex data or some formulas maybe. So how to deal with such a data, right? So we have come out with couple of approaches. Usually what we need to do is we need to work in this ETL pipeline. Okay, let me use the highlighter. So this is the pipeline which is most important when we are dealing with the multimodal data, because the challenge is how to extract the text out of
You're
it.
sharing anything, Surendra?
Oh yeah, I'm sharing. Let me, I think I forgot to
Yeah,
click on
yes,
the share
please.
button. Yeah,
Yeah, thanks.
I hope you can see now.
Yeah, yeah, Surendra, fine.
Yeah. So we are dealing with the multimodal RAG. That means how to deal with the documents which are not the plain, which are not having just the plain text. Rather, it is having some complex documents that may have some images, some formulas, some tables, and things like that. So in order to extract information out of those complex documents, what I need to do is, at the first place, I should be using different loaders. For example, I have the PDF loader, HTML loader, and the docx loader. So this is the ETL pipeline which I need to improve so that I can extract the text out of it. Okay, so this is where we will be focusing more. This ETL pipeline, how to extract, transform that particular piece of data. And we have seen there are a couple of approaches like multimodal embeddings for all the elements. Depending on the document converting, we can send the entire page as an image to my multimodal model. And the third one, which for which we have written the code, is summarizing multimodal elements. Okay, so let's look on the more detailed manner. So we will be making use of unstructured.io. The unstructured API or the library will help us to get our work done. How it will help is, first of all, let's say when we will pass our complex documents to this API, it will, first of all, what we need to do is we need to separate the images, and we need to create a list of images and then the list of tables inside my PDF, let's say. And let's say my PDF is having 10 tables at different pages. So what it will do is it will extract all those 10 images and it will create a list of images. Similarly, list of tables. Similarly, if I have a couple of images, it will extract those images out of my PDF, and then it will create a list of images. And then finally, whatever text elements are there, I will pull those text elements and I will create the list of text elements. So this is my first aim. First aim is to separate images, tables, and text. Okay, so I will create different list of these objects. Then what is my next aim is, now I will be passing my images to a large language model. But then in order to understand these images, what I need to do is I need to use some multimodal model which can take images also as an input. Okay, so the multimodal models are the models which can process not only the text but also the images, audios, and videos also. So we have, and for this, the code which we have written, we will be making use of GPT-4o Mini. Okay, so GPT-4o Mini is a multimodal model. We will make use of it to create summary of each and every image we found in our document. So this is the first thing. Similarly, I can make use of any other non-multimodal model to create summary for my table as well. If I have 10 tables, I will create 10 summaries of those 10 tables. Okay. And then finally, for the text, I will similarly create summaries of my text. Okay. By the end of this step, I will have three sets of objects, one set of image, one is the set of image, second is the set of tables, and third is the set of text. and I have corresponding summaries. Okay. Now my next step is to associate these summaries with their respective elements. Okay. If I have image number one, then the summary for that image number one will be both of these elements will be tied with the help of document ID. So what I will do is I will write some function which can create some document IDs. And when I will put these summaries into my vector database, what I will do in the metadata itself, I will set that the doc ID is 123, for example. Okay. So what I'm doing along with these summaries will go into my vector database. These complex objects will go into my document store. Okay. But then I have associated them with the help of document ID, a unique ID. And when I'm creating embedding of my summaries, I will associate doc ID into its metadata. So every embedding which we create or which we have created in the past as well, always have some metadata. For example, from which page it is coming, right? If you have a PDF of 10 pages, if that embedding or the or embedding is coming from the fifth page, always in the metadata, it will have page number 5. Along with those metadata, what I can do, I can add one more metadata manually, which will be document ID. Okay, now that information is saved in my vector database. And this doc ID is also associated with these images and tables and text, and they are stored in some other database or other document store, other repository, right? Because we don't want to vectorize them. Okay. So now summaries are now just piece of text. What we can do, we can create embeddings of out of it, and we will save it in the vector database. Now, when the question is asked, what it will happen, it will make search on these summary embeddings, and it will, when it will, let's say it has pulled 3 relevant summaries, the top 3 matches, it will do semantic search. Now I have retrieved 3 summaries, and with the help of these summaries, I can fetch my document ID, and my corresponding object from document store is also pulled. Okay, and these are the elements which we are going to show to the user. Okay, these are the elements which will go to large language model for my final answer. So I'm using summaries only to store my information which is there in my tables, the information which is there in my images, and on top of it, when I will do semantic search, then I will pull the respective images and tables and the documents and will send it to the large language model. Okay, I hope that makes sense. With that, what I will do is I will quickly open the code, okay, which we ran last time, and we faced couple of issues, but those were actually not the issues. This API has got changed actually a little bit, so I got confused. Let me parallelly open the unstructured website, the library which we are going to use. This is a third-party library. We can have multiple approaches, right? As I said, there is also something called as llama parse. Okay, what I can do is llama parse, API. Okay. So this llama parse is an API from llama index. Just like LangChain, we have llama index also, a framework for developing LLM applications. So this has one service called as the llama parse. What the llama parse will do, llama parse is the world's first Gen AI native document parsing platform. Okay. So this is also a document parsing platform. Just like unstructured, this is also a platform to which if you are passing a document, a complex document or a PDF having tables and all, it will also use large language model at the back end, and they are exposing this service as an API. You call this API, you send your PDF, it will send you back some markup language. Okay, the text format or the HTML format of your PDF. Okay, which will have all the information, summaries, and whatever. Right. So there are a lot of options. I have also tried this llama parts couple of months back, and this also works very nice. But again, it's not an open source, so you have to pay something. I think couple of calls are free. Okay, per day, I think 20 calls a day are free and then you have to pay. Okay, but this unstructured library actually offers three plans basically. So it also has an API just like Llama Index, and it also provides the platform. And thirdly, it as an open source, you can install these library on your laptop as well, on your machine as well. You can download the libraries and you can install them. Okay, so this is what we are going to do. Let me go to the documentation part. Okay, so in the documentation, so there are options like platforms, APIs. We will go to open source. In the open source, you can see all the details are mentioned, and we are more interested in partitioning. Okay, so what this partitioning means, what it will do is, if you have a PDF document of let's say 20 pages, and if you send that those 20 pages to this API or this library, sorry, what it will do is it will parse that PDF into different elements. It will say element 1 is your title, element 2 is your header, element 3 is a table, element 4 is an image, like that. So it will parse the entire PDF and it will categorize them into different elements basically. Okay, the partitioning function in unstructured allow user to extract structured content from a raw unstructured document, and it will create documents into title, narrative text, list items, and so on. Okay, so these are the different formats. If you have your .msg as an unstructured document, you can use it. So it supports almost all the extensions. Okay, so we are interested in the PDF. Okay, so which method we need to use? So this is a table, right? This is the document type. This is the partition function, which we can use. There is something called the strategies. So it offers basically various strategies based on type of content you have. Within a PDF can have only text. A PDF can have text plus your images, and it may have some tables as well. So depending on your type of content, what you can choose is you can choose certain strategies. So for PDF, we have different strategies like auto, like fast, high res, and OCR only. Okay. What is this? Okay. So this documentation you can go and refer. Okay. And so this is the partitioning. What else is important here? So yeah, I think now we can work on our this file, collab file. Okay. What I need to do, I need to install a couple of libraries. Okay. Popular utils, Tesseract, OCR. So this library basically helps to OCR your documents, OCR optical character recognition. If there is an image, it will OCR that image to find out the characters which are there on it. libmagic dev. Then this is pip install unstructured all documents. If you want to, if you don't know the format, input format of your document, maybe you can install all docs, or otherwise what could I have done is I could have simply written PDF. In that case, it would have only installed the library which is required for PDF. Okay, I will leave it to all documents. In that case, it will support different type of incoming documents. Okay. So that is, there are a couple of, this is tick token. I will be using Chroma database as a vector database. I will use tick token to create tokens out of it. So what are tokens? The words will be converted into tokens and mathematical representation. So it will take some time. Let's wait for it. Meantime, what I should do, this diagram is pretty much clear.
Surendra, for the document store, do we
Mhm.
need to use any like extras like system space or any other storage kind of thing?
Yeah, I mean, yeah, I think there are a lot of choices. What I will be using is that will be in memory. Okay.
Mhm.
Not sure if it will be able to answer. Vector database, Pinecone. So there are actually a lot of choices. You need to think which one
Mhm.
works for you, right? So I think you can use almost anything. You can also dump your documents, or I mean you can also use your laptop as well, right? Okay, so it will create some folders. Okay, it will create some document store on your local system as well. I need to see, but right now we will be using in memory kind of thing, so that your objects will remain in the memory itself. Okay.
Okay, okay, sure.
Yeah. Okay, so this is done. This is ChromaDB and tick token. Let me install that. Okay, meanwhile, I can put my input PDF. This is what I will be using. This is the PDF. Attention is all you need. Let me rename it. Attention. This is done. Pip install LangChain. Because it has to deal with images and all those things. It has to do OCR, so it downloads a lot of things, and there is a lot of processing which happens actually. This is my user data. These are my different keys which I have kept in my key store in my secrets. Done. So the first step is extract the data. Okay, as we saw in the diagram, I need to extract my data. Okay, that's the first step. So couple more libraries, I was getting exceptions. So now this is important. Okay, so what we are going to do, we are using partition PDF, unstructured.partition.pdf. So this is the library for the PDF. This is my method. So what as an input I'm giving my file path. So this is the only mandatory parameter. Okay, rest are not mandatory. So I need to give where is my input file. So I have kept my file on my collab. So I have given the path as just the name of the file because it is on its local basically current path. So this is my file, and this is what my second option is: infer table structure is equal to true. That means what it will do is it will extract the tables. Whatever tables are there in that PDF file, it will extract all those tables. Second is the strategy. As I shown on in the documentation, I have couple of strategies: fast, auto, high res, and there is one more. Whenever I am dealing with my tables, I should be using high res. Okay, so that's why I have put mandatory to infer tables. If you want your table data to be extracted, you have to use high res as the strategy. Next is extract image block types. Okay, if you want to extract the images out of your PDF, then you have to write the images also. Okay, you have to give images. If you want your tables also to be extracted as an images, you can give tables as well. But in that case, they will be extracted as images. Okay, but we are more interested in inferring the table structure. We want to go inside the table. We want to read each and every row, and we will be converting those tables into HTML format. Okay, that I will show you. So far, so good. The next is extract image block to payload. This is another parameter which is important, which when made true, what it will do is when it is extracting the image, it will also make one metadata which will convert it into base 64 format. Why do I need images to be extracted as base 64? Because this is the format by which I can show image on my user interface, and while calling or while sending these images to my multimodal LLMs, I need to pass them as a base 64 format. So I need that format for passing my image bytes to my large language model. Okay. Other than that, this is again uh, more important. What is my chunking strategy? In the last class, I show if you comment this particular part, if you run your this particular method, what it will do is it will create numerous chunks. It will create around 118 or 17 chunks. Okay, so what it will do, it will go and find out the different elements, as I said, and it will create some chunks out of those elements. But what I want is, I just don't want the each and every element to be passed as is to my language model. What I want is, I want to club those elements into some logical group. So what logical group I can make is, let me open that PDF. So this is my PDF, which I'm giving as an input. In this PDF, you will see there are a lot of things, right? There are images, there are some headers. This is your title abstract, and then you have this introduction, you have background, and you have model architecture. So there are basically different topics or different titles. In the model architecture, what we have some text. We also have one image. We also have some more text. Okay. And we have some subheadings, encoder and decoder, and all those stuff. So what I want, the different elements which are passed by my library, they should be stacked together or they should be grouped together as per the title. If my title is scaled dot product, then this text element along with this element which will have this formula, and if it is having table or images, they should be combined together. Okay, so I want that chunking strategy. Okay, in case of our regular RAG, what by when we say chunking, we are actually splitting into smaller parts. But in this case, we are actually clubbing different elements into bigger chunks, or the chunks which are more relevant together. Basically, the elements which are same or which are coming under one title, we are clubbing them together so that that makes some sense for me and the information is not segregated. Okay, so that's why I have said that I want the chunking strategy to be by title. And these are some parameters which will define the maximum size of my chunk. And if I also don't want that my chunk should be very small, right? So I'm saying combined text under the characters 2000. So it will not create very, very small chunks. It will combine those. Let's say when I say by title, maybe I'm having two different titles in a span of just 2 lines. So I don't want those 2 lines to be converted into one chunk. Okay, what I want, that chunk should be a bit bigger. So I'm telling the maximum size, minimum size, and some other parameters also. So this you can actually refer in the library for more details. But yes, our aim is to create chunks by title. I hope this is clear. So earlier, without having this option, I would have 117 different chunks. Now, by having this one, if I see what are the different type of chunks, I will see it's a composite element. Or is it making sense, guy? Are you getting confused or is it okay? समझ में आ रहा है? Yes, no.
Yes, Surendra, yes.
You are watching match. Tell me.
No, you're getting, yes.
So we are giving by title. So that's the reason whatever the data is going to be based on the title only, it is going to be chunking, like, or it's grouping.
Correct, correct. So let me actually run it again by commenting this line and just see. It will
Yeah.
create some 118 chunks.
So in that time, so on which basis it is going to be chunked?
Yeah. So when I will run this command, so what it is doing is it is basically those will not be chunks, but those will be elements actually, different elements. Okay.
Okay.
Okay, my bad. So at first, when I don't when I comment this code, it will extract all the elements. For example, my first element will be this one. My second element may be some text. My third element may be some formula. My fourth element can be a table. This table, my fifth element is like so. Like that, it will extract 117 or 18 different elements. Okay, but
Okay, so
now
there is no specific, so it is not going to be take any index or nothing. So it is just
exactly.
by default, whatever it is there, it is going to take.
Huh. It will just parse into different elements and that's it. In that condition, if I load my data, and so what it will do is there is no relevance among those chunks basically. So what I not chunks, those elements. So what I want is I want to group those elements into some uh, uh,
By title.
by title so that relevant elements are grouped together in one chunk. One chunk should have some relevant elements. That's it. Okay.
Mhm. Yeah.
It will.
So let's say in the one title, if we are defining this character limits, right? So in that, if
Mhm.
the characters are less than how it will be like, it will take the next title in that based on the size, but we have defined max and all.
Your
Uh,
voice is breaking. I'm not sure it's only for me.
No, for me also, not able to hear properly.
Can you come again, Aman? I think it was Aman, right?
uh, no, no,
No, I think there is some bad network at your end. I thought I will finish it
uh,
off in 30 minutes. Yeah.
now isn't,
Yes. Yeah, better,
yeah,
better, better.
yeah, no, I was like, my question is like, now we are doing the chunkings like based on the characters title
Mm.
and we have defined characters, right? Like
Mm-hmm.
character limits. So if like under one title, if the character limit is less, like let's say 2000, but we have
Mm.
defined 10. So it will take the next one also in that, or only just grouping based on the title, whether it's less than defining limit, the
Yeah.
character
So,
limits.
yes, we are saying the maximum number of characters should be 10,000. Otherwise, my chunk will also be very large, right? So I want to limit that. And if let's say there are titles which are coming very frequent, okay, so what it will do is it will combine those titles into one chunk basically. So my
Okay.
chunk size should not be less than 2,000. Okay, so that's what we
Okay.
are defining here.
Okay. Okay. So in that case, maybe few of the chunks may have not the relevant things in that when
No, I mean that's
group.
fine, right?
Okay.
Let's
Yeah, that's
say.
it.
Hmm,
Mm.
even if I group two titles, for example, if I group 5.1 and 5.2, that is fine, right? It has some decent details. Okay. Or sometimes what happens, maybe let's say by mistake, it has understood that this is a title, right? And then if I don't define that minimum, it should have 2,000 characters, then what it will do is it will create one chunk only of this particular title, which it has
Mm.
misjudged. So in
Right.
order to avoid those things, what we are doing is we are also defining that at least there should be these many characters in one chunk.
Okay. I got
So now without this strategy, if I see what are the different type of chunks, what I can see is these are the unique types basically. Means email address is there. So there are couple of email addresses. So email address, if I see, 1, 2, 3, 4, 5, 6, 7, 8, 9 email addresses. So that there will be 9 elements of email address type. Okay. Right now, this is a set basically. Whatever chunks I have received, I am just trying to get the unique chunk types basically. Okay. The type of this element, unique types. Email address. There are a couple of email address elements, couple of figure captions, footers, formulas, headers, images, list, and all those things. Last time I was confused because earlier they had API where this table was not included. It used to come separately. Okay. So now they have not here in the next step. I will tell you. Okay. So there are text element and title element. So these are the different type of my elements in my document. I hope this is clear. But if I say what is the length of my chunk, not this I'm specifying as chunk, but these are actually elements. This is 217. So there are 217 elements in total, and they are of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 type of chunks, 11 type of elements are there. Okay? That's fine. Now what I want to group them together. So I will uncomment and I will run it again. So instead of 217, it will just produce 14 or 15 uh, chunks basically. Right now, email address, it will club all those things and it will create one composite element. Okay, guys, it will create one composite element and it will include if within one particular title, under one title, if you have 10 email address, one figure caption, one footer, and one formula, it will club all those and create one composite element. ठीक है? इससे ज्यादा अच्छे से मैं नहीं बता पाऊंगा. Okay, guys. Okay, let it run. I have stopped following the cricket for last few years. I don't know why. India 247 yet to bat. Okay. India will win. Probability of India winning the match is high.
Yes, too high.
Less? Too high, yeah. So if you are having interviews, if you say I have used unstructured API, unstructured library, these are the 3 different ways in which we can use. What I did was you just explain all these things, and I bet that person will be highly impressed. Okay, if you tell this level of details, okay, and then if you tell the details about your LangChain, how you are creating those runnable pass through, what is runnable, what is a chain, what is Langsmith, I think you can easily crack the interview. To.
Sundar, one thing is like, can we have all like this recordings in Google Share Drive path in one order, like lecture one, lecture two? Because now in WhatsApp,
Mm-hmm.
it is up and down while searching which one.
Mm-hmm.
Getting confusion. Getting
Mm-hmm.
confused actually.
Okay, I can do that. I can do that, but the amount of space it will occupy on Google Drive, that can be huge because I think every recording is of, I don't know how much in GBs maybe or in MBs. If it is in MBs, then I think yeah, I can do that.
Maybe if see like if you can zip also, that is fine. We can
Mm-hmm.
download
So
unzip.
zipping videos, I don't think there is lot of compression.
Mhm. Okay.
Abhishek Sharma.
I wish 100, yes.
Who is Abhishek Sharma? I'm hearing this name for the first time.
युवराज का चेला.
युवराज का. युवराज
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 सिंह के
सिंह.
चेले.
अच्छा.
उसके.
Tilak Verma. This is also first time I'm hearing. Surya Kumar is Shivam Dubey, Hardik Pandya, Rinku Singh, accepted. Quite a different team. I mean, lot of youngsters, I think.
Yeah. Except two, all are
If you are not
new only.
following last 2-3 years, then definitely you heard about Shami and
Yeah, Mohammad
other guy,
Shami.
Sham is
Hardik
back.
Pandya.
This
Hardik
Hardik Pandya.
this
Hardik Pandya.
Is this Ravi Vishnu is from Jodhpur.
Yes,
Okay.
Vishnu is from that.
I met him actually. One of my friend deals in the property. He's a property dealer kind of. So he sold couple of plots to Ravi Ravi Vishnu. So he's investing. Good. Okay, so this is done. Now when I run, what are the unique chunks? I will get only one unique chunk because it is clubbing different into one composite element. Composite element. This is the unique chunk. And how many such composite elements are there? There are just 12. Okay, it has grouped different elements into composite chunks. Very nice. So last time what was happening is along with this composite chunk, it was actually not clubbing the tables. When I ran this code couple of months back, it was showing the composite elements and one more row of table elements. Now what they have done, they have put the table also inside the composite elements. So I was confused. Anyway, so there are total 12 chunks. We have reduced the elements from 117 to 12. Okay. Chunking does not mean we are making them smaller or more in the number. We are actually increasing the size and we are less in the number. Okay, good. So if I go and check any specific chunk, let me see if I want to see the 10th. This is a composite element, the thing exciting. Now what I will do is, what is my next task? My next task is to segregate. Okay, images, tables, and text. Right now I have the composite elements and everything is stacked in that composite element. Super. So what I'm doing, I am taking the fourth chunk, I am going into its metadata, then original elements, each composite each chunk is a composite element and in itself it is having multiple elements. Okay. And if I iterate those elements, I have taken the fourth chunk and I fetched all the elements which are there, which are of type, text, image, and tables and all that. If I iterate that list of elements, and if I match, if that the type is like image, then I am displaying that image. Okay. Not displaying, I am just converting it into dictionary. So the metadata is having image. So the image element, the type is image. This is the element ID. This is the text. And this is the base 64, which I wanted to show you. Okay, so the metadata of my image type of element is also having a metadata, which is base 64. So this is that base 64 encoding of my image. Okay, and this came out in the metadata only because I put this option while defining my function as a parameter, which is last time also I got confused. So base 64, right? This one. So when I say true, it has added the base 64 representation of my image in the metadata. If I make it false, I will not get it. Okay. So I have got that image base 64 representation. Nice. That was one thing which I wanted to show you. Now what I'm going to do is, whatever composite elements are there, I am stacking them together in the text. What is my next aim is to create these three lists. Okay. Images, tables, and text list. So I have taken those chunks and created this text list. If I see, all are basically my composite elements. It just stacked together all those and it created a list of text. If I need to get the tables, what I need to do, each of these composite elements will have different type of elements. So I will match, I will iterate all the chunks I will iterate for chunk in chunks, and I will see if the inside element is is of type table. If it is of a type table, what I will do is I will add that in the tables list. Okay. Essentially, I'm going into each and every chunk. If the inside elements are of type table, I will take that table out and I will append in this particular list. So by end of this method, if I call this one, I will have all these tables. Okay. How many tables are there? There are 4 tables basically. Good. And what it does is it basically converts the text as an HTML. So if I read this properly now, I will see complexity per layer, sequential operation. So it has created the HTML representation of my table, which is having header and all the information, maximum path length and all the information of my table has came down to in the HTML format, in the text format basically. Okay. And if I see how many such tables are there, there are just 4 tables. So in my PDF, I can see how many tables are there. If you count, that count will come down to 4. Okay. So it has taken, we have taken out all the tables out of my PDF document and I have grouped them. For example, this is a table. Okay. Table number 2. Table number 3. Table number 4. That's it. There are four tables and we have successfully pulled those 4 tables out of my document. Similarly, images, how many images are there? There are 7 images. So I have extracted 7 images and I have put in my list. Okay, this is exactly what my intention was. I have stacked all the images. I have stacked all the tables. I have stacked all the text. Super cool. Okay. Now my next step is to create summaries. Okay, let's have a look on one of these images because we have base 64 representation. We have one method which can show the image. Okay, so this is that method. For example, in my images list, which I have just created this images, which is having 7 images. If I want to see this first image, it is of second image. 0 is the first image, first is the second image. So this is my image. If I go and see my second image, that could be other image. So we have successfully extracted all the images. Very nice. Okay. Now our next step is to summarize all these things. Okay. Go back to diagram. Now we will be sending these images to multimodal LLM and then to simple LLMs. I will create summaries out of it. Let's do it now. So let me install LangChain. So I was trying Grok actually. This Grok exceeds the limit. The number of elements or the number of tokens which I am passing is actually exceeding the free limit. So for text and tables also, what I'm doing is I'm using GPT only. Okay, but ideally you can use any non-multimodal. Maybe I can use GPT-4 or GPT 3.5. Okay, so this is my prompt. I'm saying you are an assistant task with summarizing tables and text, and here I'm passing my element. Okay, and this is my prompt. This is my prompt text which I'm passing to my prompt, and this is my small chain which is having 3 steps: prompt, model, and output parser. When I invoke this chain, let me run it. This is clear, right? अगर आपको कुछ doubt हो तो do stop me. So I will run the batch. I had the list of text. I have passed all those text into this chain. What this chain will do, it will say, this is my element, create summary of this element. Second piece of text, this is my text, create summary of this text. So it is creating summaries of my text. End of it, I will get some text summaries. I had 12 different text elements. If I see those text summaries, these are the summaries. If I say Control A, Control C, go into Notepad, and I paste, I can see How many are these? First, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. So it has created 12 summaries of my text elements. So far, so good. Similarly, what I will do, I will go and create summaries of my tables. Okay, for tables, as I said, the table will have an metadata element, just like image is having 64, base 64 images. These tables will have one metadata as text as HTML. So I'm converting my table into HTML format, and I'm passing those HTML to my large language model to create summary of all the tables. Okay, so if I see my one table element, you will see here I have as text as HTML as a metadata. Okay, so I'm part
So, you know,
hmm,
maximum concurrency 3
is
means.
basically is we are using batch, right? Usually we do
Hmm,
chain dot invoke, so that is one call. So now
hmm,
we have multiple elements in my list. I want to use batch operation. Not for each element I will go to invoke my model. I will be doing in the batches of 3. If I have 12 such elements,
hmm.
3 of those elements will go in one call, in one batch. It will go, it will do the operation, it will get the response. Now next 3 will be sent to my
Okay.
LLM to
3 at
create
a
the
time.
3 at a time, maximum 3.
Hmm,
Okay, so
okay.
that's, so now I have got my table summaries also. ठीक है, कितनी tables थी मेरे पास? I think 4. Let me copy paste this as well on my notepad and just see how many summaries we have. We have 4 summaries. Okay, just read the table, compare the 4 layer types in the terms of complexity. It has created this level of summaries. Very nice image. And then, so the image will have a different prompt because we actually need to pass the base 64. So for that, we need to create this prompt and message in a different way. Okay, so what we have to do is we have to say type is text. This is the prompt template. Describe the image in detail. For context, the image is a part of research paper explaining the transformers architecture. Be specific about graphs and such as bar plots and all. So this is my instruction, and here I'm passing the actual base 64 content of my image. Okay, that's why I use that option in my uh, partition PDF method. Okay, so this is my prompt. These are the messages which are associated, and this is my chain. I will again do the batch operation. Whatever images I pulled from my PDF, I will be sending all those images. So it has created summaries of all of my PDFs or all of my images. How many are these? 1, 2, 3, 4, 7. Okay, so 7 images. And it has created the image depicts the architecture of the transformer model often used in NLP. It is structured as a flow chart. So these level of details are covered. Long summary of the images. Super. Now you know what is our next step. This is one of those summaries. Okay. Our next step is to load all these summaries. Now I am on this step. Okay. I hope this is visible. I have got the
Yes,
summaries.
yes.
Now I will be doing what? I will be associating document IDs to them, and then I will vectorize it. Okay. What I will do, Chroma database, Chroma vector database in memory stored from the LangChain, and the document you already know. LangChain document OpenAI embedding model I will be using to create my embeddings, and I will be using multi-vector retrieval, which is a very good library in LangChain itself, with the help of which what I can do, I can create the retriever. I will be passing the vector store, the document store, and the key which will associate it. Super. When I define vector store, this is my chroma. This is my collection name. This is the embedding function I will be using to create my vector store. And this is my in-memory store. Where from it is coming? It is coming from LangChain. And this is ID underscore key is my doc ID. I'm passing all these three, vector store, document store, and ID into my multi-vector retriever. Okay, you can try something else also. Okay, you can explore on internet what are the different options, but this is very convenient. This retriever from LangChain is very convenient. You can just pass these two along with your IDs. Okay, now let's load these one by one. I have defined my retriever and my vector store and doc store. Now I'm creating the different document IDs. As I said, this will create some unique IDs. I will now see, this is important, when I'm putting my summary text. Okay, what I'm doing is my page content is the summary. Okay, one of the elements of this summary text which we have created. Now we are talking about creating, we need to store them in the vector store, all the text list. Okay, the list of text basically. So while creating, as I said, in the metadata, what I'm going is I'm going to provide this ID underscore keys as doc IDs. I will iterate through the doc IDs which I have created, and for every embedding I am associating in the metadata its ID, its doc ID. Okay, so it will iterate through all the text summaries, it will create embeddings, it will associate the doc IDs, and then we will add all those documents into my vector store. Similarly, I will add all my original text. Okay, this text, the list of all the text elements into my doc store. So in my RA, this is how we will add all my text elements. This is how I will add all my table summaries into the vector database and the tables itself into my doc store. And finally, the images will go into my document store. The image summary will go into my vector store, and to every image summary which is going into vector store, I am associating some metadata which is image ID. Okay, this may look a bit complex, but I hope you are at least getting conceptually. Okay, so we have sent them into their destinations. These have reached into document store. These have reached into my vector store, vector database. Okay, now my retriever. Who is multi-head attention? What is multi-head attention? So it is able to fetch these four chunks. These four chunks are what? They are the summaries, or they are the documents from the document store. What are these? These are not summaries, right? This retriever will
Right.
help me. This retriever will help me to pull the original elements which we have put in the doc store. Okay. So I can see in my output, this is the composite element, second is an image, third is a composite element, and fourth is also a composite element. Okay, so as per my question, what it has done, it has pulled these four relevant composite elements and one image. Okay. This may look, I don't know, a bit complex, but this is how it is. And now what I'm trying to do is I'm seeing in one of those chunks what I see. For example, in my first chunk, I'm just iterating through all these four chunks which are produced as an output. So I see in my chunk 0, what I'm having is I'm having this title from the page 4, narrative text from the page 4, and then formula from the page 5. So this is the beauty, right? This is why we put our we created the chunks by title, because my one chunk is having all the related data. All the data which was there on the page 4 and page 5, they have been clubbed together and have been put into 0th chunk. This is my next chunk. Okay, and this is my 4th chunk. Make sense? I can see the data which was together in my PDF. This is, I'm actually printing this page number. Okay, so that's why it is showing me the page number, and I'm telling I'm also printing the type of my element, doc dot to dictionary type. Okay, so this is getting type from my metadata. From this to dictionary, the output, it will pull the type of the element, narrative text, and this is the page number. Okay, so the first chunk is having all the related content, related elements inside it. Super cool. Okay, and the image, the second element was image, right? So image, if I display, this will come out to be this image. So my retriever was able to pull the relevant chunks as well as the image. This is what I wanted at first place. Now we can create these RAG pipelines. So I have what, this is a bit complex coding, but maybe you can try to understand this. I will give you some high level overview. Okay, so what I'm doing is I'm creating these two chains. Okay, this is chain number one and this is chain with sources. It is doing nothing. Okay, and I have couple of these helper methods. Okay, for example, I have this build prompt, I have this parse documents. Okay, so what it will do, when I do chain dot invoke, what it will pull the relevant results. The retriever will pull all those chunks from my document store, and those will be passed through my runnable lambda, and this function will be called, which is called pass document, and this is runnable pass through. Whatever question which I asked, it will be passed as is to my build prompt. Okay, so this prompt will receive context and the question as well. Okay, and then it will give it to the chat, this model, and it will create the final output. This is a bit different in the sense that I'm actually creating a dictionary. As a response, I have the context, the question, and enable pass through dot assign. It will also have third element. My dictionary will have a third element of response, which is having a chain inside it. Okay, चलो इसको रन करके देखते हैं. I think this is a bit complex code. You can take your own time to understand this at a later point. So now my question is, what is blue score for model by net? Let me see. Okay, so now I'm asking a question about something which is inside my table. So my question is what is blue score for the model ByteNet? So this table is actually giving the blue scores. Now you can see this is such a complex table. It has one header as a model, another column as a blue. This is English. I don't know what is DE, German or French. Not sure what it is. EN and EN, DE and FR. And then these are the training cost. So I'm asking a question from inside this table. For example, what is the blue score for this model ByteNet? Okay, and let's see if it works. It does work. It says 23.75. 23.75. Now you should be able to appreciate this piece of code. If you forget about unstructured, and if you try to hit the YouTube and you try to do something like this, which can actually parse your which can parse your table and can get the data from its rows, that will really be very, very difficult, right? Because I tried myself. So I had to spend some 3-4 weeks, and then finally I realized unstructured.api is what the good solution, at least the free solution, which you can use to create POCs and all. There are paid options like Llama, Parse, and other, but now you can see if I say, let's say, what is the blue score for some other thing, GNMT. Plus RL. Not sure it will be able to answer, but let's see. The blue score for model GM plus RL is 24.6 for English to German and 39.92 for English to French. 24.6 and 39.92. Wonderful, isn't it? I mean, I got impressed when I saw this first time. Really, this is going into that much of detail successfully. Okay. So that is why this unstructured API is so important. Even if you have tables in your data, it can successfully. I mean, just think from the application perspective. If I am an engineer and I am at my site, okay, and I'm doing some operation maybe in the sea, right, and then I have a manual which is like some SOPs which are like 1500 or 2000 pages long. If I need to find out such a minute information, then it will take a lot of time to find out, right? What I can do is I can build these applications like which are based on Gen AI, and what I need to do is I need to simply ask my question, and then it will be able to answer based on the tables, the catalogs, or whatever I have in my PDF. Okay. All right. So now, if there is the other chain, if I ask what is attention mechanism explained with image, what it will do is it is taking time. So it's giving image response. The attention mechanism is a critical component in a neural network, particularly in blah blah blah. Explanation of attention mechanism. It is telling me what is attention mechanism, and it is also giving me such nice images out of as an uh, result. Okay. Yeah. So this is what the multimodal RAG is. The concept is extract your elements, create the summaries, put them into the vector database and the doc store, get your questions, retrieve from the vector database the relevant summaries. The relevant summaries are stacked with the document IDs. You pull document ID and you pull the relevant element from your Docker store, and you throw it all those elements to the large language model. It will interpret the information and it will send you. Okay. So this is it for today, guys. You have any questions, do let me know. I will share this code again. Okay. You can spend some time, you can run this code and let me know if you have any questions.
So one quick query is Surendra. So while we are displaying the images, right? So when we are processing that from the PDF, how this is going to be internally, it is going to be it is going to be convert that image into the some code, and then when we are extracting that one, it is showing into the image, or directly image itself, it is going to be stored into the doc database. I mean, how?
Yeah, I mean, your images are actually stored in the Docker store as is. Okay.
As it is.
Yeah.
Okay. Mm-hmm.
So once you get your response from the vector database, they have document IDs. It is internally searched from that doc store and it will pull that image.
Okay, fine. Yeah.
This is good, Surendra. We'll try it.
Yeah. Please try. This is very important. Okay.
Yeah.
And yeah, enjoy the match also, guys.
Thank you.
48 for
Thanks.
1.
Fine.
All right, guys. Thank you
Yeah.
so much.
Thank you.
Thanks.
Thank you.
Bye-bye.
Yeah.
Bye.
Bye.
Bye. Bye.